Hello and welcome back to Curtitus Math. So in this video, we're going to be looking at polynomial division. So just a little quick reminder of division vocabulary. So we have three main words here: the dividend, the divisor, and the quotient. The dividend refers to the number that is being divided. The divisor is the number that is doing the dividing. And the quotient is the answer that you get when you do a division. Okay, and then there is three different ways, three main ways that we denote divisions. The first is by putting this fraction line, so all fractions are divisions. The other is this, doesn't actually have a fancy name. A lot of people just call it the long division symbol. So this long division symbol, it's kind of like a parentheses and then a vertical line on top. That kind of boxes in the dividend. And then we have our classic division symbol, the little horizontal line with the two dots. Okay, so the first thing that we want to do when we have a polynomial division is that we want to set it up as a long division. So that's the first thing we're going to do here is x squared plus 7x minus 18. We're going to put all of that under a long division. There we go. And then we're putting the divisor over here on the left. So x plus 9. And this is quite different than the other types of divisions that you've done up to now, since now we're dividing by a binomial. We have two components here. But the way that we do this is we really just need to focus on the first. Okay, so we're going to start with focusing on this first term here, and also focusing on this first term here. So the question that we're going to ask ourselves is here, what do I need to multiply x by in order to get x squared? So in order to get x squared, we have to multiply x by another x. So here I'm going to put an x. And now if I was to do x times x, I would get x squared. And now this is where the second term comes in. Now I have to follow through and distribute this x to the second term as well. So now we have x times 9 plus 9x. And now that gets distributed here. So notice how my terms, my degrees are kind of lining up. So I have my x squareds together, my x's together. And now we're going to do what we always do in long division, is we are going to subtract these. So something that might be helpful is put little brackets here to remind you that when you put this subtraction, you have to distribute that negative everywhere. Okay, so now we have x squared minus x squared, we get 0. That's what we expect. And now we have 7x minus 9x. We're going to be left with minus 2x. And now we drop our 18 down. So negative 18. All of that gets dropped down. And now we do the same thing that we did in the last step. So we're going to focus on the first term here, and again on that first term. So first term and first term, we're asking ourselves, what do we need to multiply x by in order to get negative 2x? That would be negative 2. And now we follow through in the multiplication. So we have our minus 2 times x. We get minus 2x. And minus 2 times positive 9. We get minus 18. And now we see that these are exactly the same. When we apply our negative, these will all turn to positives. And we get 0 and 0. So the quotient here, our answer, is this up here, x minus 2. Okay, so now in example number 2, this is going to show you one of the kind of tricky things that can happen with polynomial division, and this is when you are missing powers. So we'll give this a little title. So missing powers. So here we're going to do the same thing and set this up. So we have 4p squared minus 16, and that is being divided by 4p minus 8. Okay, so we're going to do the same thing here. And we're looking at those first two terms. So what do we need to multiply 4p by in order to get 4p squared? That would be just p. So p times 4p, we get 4p squared. And then we're following through in our multiplication. So p times negative 8, we are going to get negative 8p. And now when we do our subtraction here, so this would turn to subtract, this would turn to plus, this is what we see happens. This is fine, it cancels out and we get 0. But these here don't match. This is a constant, and this is a term with p. And if we look up here, what happened is that when we did that multiplication by x, so we did x times x, we got x squared, and then we did x times 9, and we got 9x. The 9x was sitting directly under the 7x, and those matched. But in this case, this isn't happening because in our original expression here, our dividend is missing a power of p. It doesn't have a term that has just a p. So we actually have to fix this. And this is the fix that we need to make. So I'm going to take my 16 here, I'm going to shift it over, and I'm going to add, I don't want to change anything, so I'm adding 0p. And I'm doing that 0 is really just a placeholder. So it holds the place for the p's that will eventually pop up from this multiplication. So now I can do this operation. I have 0p plus 8p, and now I have 8p. And I can take this and drop that down, minus 16. And now the rest of the process is the same. Here I'm looking at my 8p, that's my first term and my first term. I'm asking myself, well, what do I have to multiply 4p by in order to get 8p? That would be 2. So we're doing plus 2. 2 times 4p gives us 8p. 2 times minus 8, that gives us minus 16. Here when we do our subtraction, the signs change. 8p minus 8p, 0. Negative 16 plus 16, also 0. So we're good here. Our answer, p plus 2. Okay, so this was the missing powers example. So here we have to add a placeholder for the missing power. And I'll highlight this as well. Okay, so now we have our last example. So we're going to do the usual setup. We have 5x plus 9, and that is dividing 5x squared minus 16x minus 49. So we're looking at those first two terms, and we're asking ourselves, well, what do we need to multiply 5x by in order to get 5x squared? That would be just x times 5x. That's going to give us 5x squared. X times 9. That's going to give us positive 9x. Now we have to do our subtraction, so these signs are going to change. So 5x squared minus 5x squared, we get our 0. And now minus 16x minus 9x. That is going to give us 25, minus 25, I should say, minus 25x. And our negative 49 drops down. Now we have the same thing. We look at our first term and our other first term. What do we need to multiply? Negative 25, or sorry, what do we need to multiply 5x by in order to get negative 25x? So pay attention to that negative here. That would need to be a negative 5. And when you do your multiplication, you are testing it out, right? So minus 5 times 5x, that gives you minus 25x. And then minus 5 times 9, that's going to give you minus 45. So now we have to do our subtraction, which means we are putting in a negative on the outside here. So if we had brackets and a negative, it's going to get distributed. So here we're going to have plus and plus, and we have negative 25x plus 25x, we get 0. Negative 49 plus 45, we get negative 4. So now we have a negative 4 left over. That means that we have a remainder. So this example has a remainder. We can write remainder negative 4. And we have to think about, well, what happens when we have a remainder? What do we have to do with that? So we're going to think about, so this is just like a little reminder here. So think about, let's do 5 dividing 321. Okay, so what did we do with normal long division? So that was the same thing. Here how many times does 5 go into 3? 0. How many times does 5 go into 32? 6. We get 30, 2, 1. How many times does 5 go into 21? 4. 4 times 5, 20. Subtract 1. So the way that we would write this, 64 and 1 divided by 5. So this remainder 1, this turned into 64 and 1 over 5, 1/5, because we have one piece left. We're cutting it up into 5 pieces. So 1/5. So similarly, over here we have negative 4 left over, and that negative 4 is being divided by all of this. So this answer would be x minus 5, and then minus 4 over 5x plus 9. So it's that same situation as when you have mixed numbers. So this is kind of something you learned way back in grade 7. So it's coming back now. The same idea of you have your quotient and the remainder, and you put the remainder over the divisor. Okay, so this is the remainder. So this is the other kind of non-standard remainder. So in the package, you have the first 8 questions are just standard. There will be no remainders and there will be no missing powers. Okay, in the next 4 questions, I'm telling you, watch out for missing powers. They don't all have missing powers. That's just how the program makes the questions, but I checked the box that said you can include missing powers. So it added some in. And then over here, I wrote watch out for remainders. So these 4 questions may have remainders. And then in the last one, okay, these ones over here, divide the polynomial. These are just more like they're larger polynomials. So these all have up to degree 3. And then the last 4 examples, watch out for everything. So missing powers and remainders. Both might be present. They might even be present at the same time. So remainders and missing powers. Okay, so that is it for polynomial division. I'll scroll back up here. Okay, so if you have any questions, feel free to leave them in the comment section of the video. You can always ask your math teacher if there's a particular example that you need some help with, and you can always come by the math office, and a math teacher will be happy to help you. All right, I will see you in the next video.